For locomotion, we decided to keep the design from previous labs. This gave us a familiar form of transportation to work with and would work well on the terrain of the course. Decided on the ultrasonic sensor for navigation because it was the agent that led to the most successes in our experimental trials. Since it relied on proximity over colors or touch, it provided a more diverse navigation tool for this course. We decided to use the colored sensor over the light sensor since we were more familiar with it due to its incorporation in previous labs. But instead of recognizing colors, we programmed it to recognize light. We used the touch sensor as a trigger to start the robot. Since it's located on the top of the robot and must be pressed, it was the least likely trigger to experience error that we had at our disposal. For our strategy, we decided to split the robot's program into two parts. The first part prompted the robot to move forward until it reached an obstacle. From there, it would turn left, avoiding that obstacle. It would proceed until it sensed something in front of it again. It would then turn to the left and to the right to see if it's in a corner. If it wasn't in a corner, it would proceed to the right. The robot would repeat these steps until the second part of the program started. The second part of the program signaled the robot to stop. It would then perform a 360-degree scan of its environment. Using its colored sensor, it would scan for a light source while it was turning. Once it located a light source, it would proceed to the source until it reaches it. From there, it would maintain a set distance until the time limit was up. Here's an example from our experimental trials depicting the first program in action. As you can see, it navigates around the box by turning to the left. When it reaches the next box, it looks left and right to ensure it isn't trapped in a corner. When it decides it's not trapped, it moves to the right and proceeds further into the course. This example demonstrates the second part of the program, where the robot scans for a light source. As you can see, once it detects a light source above a certain threshold, it proceeds to follow it until the timer runs out. This next clip is of the Getting Around challenge performed in class. This is where all our hard work came to fruition. During our experimental trials, we tested out several different ways to navigate the course, ranging from hopping to bulldozing to even a touch sensor at one point. Eventually, we ruled out each one of these methods, either due to its unpredictability of the course or because it was just plain impractical. There were many trials and more than a few failed prototypes, but eventually we found a system that worked. And as a result, we found our final project, the robot that you see before you.